Our urban environments are dominated by the buildings that we work and live in. The environmental impact of constructing these buildings is significant as they contain a vast array of materials, many of which require highly intensive manufacturing processes that result in resource use and pollution. Many schemes have evolved for evaluating or rating the impact on the environment of buildings or products used in building. The most detailed and quantitative analysis is known as a life cycle analysis, or LCA, and its application on building projects is increasing as governments, regulators and clients are demanding more environmentally friendly buildings. LCA provides a systematic approach to measuring resource consumption and environmental impacts associated with products, processes and services. Designers need a tool that is quick and easy to use that provides a detailed environmental analysis at the design stage. The Australian Cooperative Research Centre for Construction Innovation has developed LCADesign to meet this need. LCADesign is an automated eco-efficiency design tool for commercial buildings. The LCADesign solution involves the use of 3D CAD models to gain building element data, the automated calculation of individual material quantities, the linking to local Australian emission data, the use of key environmental indicators, and finally, the provision of graphical analysis of design alternatives. The LCADesign process starts with a 3D object-oriented CAD model. These models provide the details of building elements that are contained within a building, including their dimensions and location. However, the building models are often not detailed enough to enable specific product information, so the LCADesign tagging tool was developed to allow a specific product in the form of material content and dimensional scaling rules to be quickly and easily associated with a CAD object. These rules enable a detailed material breakdown to be calculated for each building element. Once tagged, the model is exported via an IFC file, which is the internationally accepted standard for 3D CAD model data transfer. The essential data for calculating environmental impacts of building materials is a life cycle inventory of the common building products used in constructing a commercial building. The scope of this database includes Australian and overseas processing environmental impacts involved in acquiring, processing, transporting, fabricating, finishing and using metals, masonry, timber and other components. Environmental impacts are classified, calculated and reported for all flows of raw materials, fuels, energy and emissions to and from the air, soil and water. The indicator used to measure environmental impact has 12 impact categories, such as carcinogens, radiation, climate change, and ozone layer, which are aggregated into a single score by combining data from the 3D CAD models and the life cycle inventory database. LCADesign brings together 3D CAD modelling and life cycle analysis to provide insight into the environmental impacts of all components of a commercial building in a way not previously available.
We've seen such an evolution over the last few years of things that we just weren't able to do or imagine even a few years ago. For example, dynamic modelling of energy and greenhouse from buildings. The tools weren't available to us a few years ago, and they continue to increase in their sophistication and in the way we use them, which has given us sort of more understanding, more ability to do things.
LCADesign provides a new capability, adding considerable value at the design stage. Environmental assessment direct from 3D CAD saves time compared to existing practice. LCADesign can assess individual components or a whole building in one step. LCADesign can readily vary the components of a building to quickly evaluate the environmental impact of alternative designs, such as the options for facades. While focusing on life cycle assessment to determine relative impacts of a building on the environment, LCADesign also provides a range of additional indicators in the one tool. The alternative indicators include embodied energy, embodied water, carbon dioxide, and combined greenhouse gas emissions, as well as a measure of carbon content in anticipation of a carbon content trading. Drilling down to component level can identify hotspots.
Anything that we can do to eliminate the physical hours of technical input into coming up with an answer and also enable the process to happen very quickly with the design evolution, gives us an enormous advantage and ability to more significantly influence the design development of the project from an environmental aspect, whereas at the moment we're very reactive as opposed to being proactive. So that's by far and away the most outstanding feature of the concept of the program.
LCADesign is a unique integration of technology, databases of environmental impact of materials and assessment measures that provide an innovative tool for designers and architects to assess the environmental impacts of the building as the designs are being created. Use of such a tool drives innovation and results in buildings with minimal environmental impacts, benefiting the owner, user and community. LCADesign has been developed through a collaboration of industry, government and research partners as a project of the Australian Cooperative Research Centre for Construction Innovation.